All right, so as maybe a couple more people are logging on, I'm going to take a couple of minutes and introduce our two co-presenters and myself. I'm Floyd Smith, and I'm Director of Product Marketing at Tetrate. Relatively new addition to the company, and privileged to work with these two gentlemen who actually represent probably the three things that we're best at between them. And they cover the gamut from A for Adam to Z for Zack. And Adam is based in Charlotte, but he's actually in New York today, working with customers. And we're known for two things, and one of them is outstanding care for our customers. So we get to work with some of the largest organizations in the world, and medium-sized and smaller organizations as well. Some of the people we work with have extraordinary demands of their computer systems. And every time we add one of these complex customers, we get to learn a lot about how people really push service mesh, security, software agility to the limits. And Adam leads up that effort where we go. And again, we say that we're doing solutions engineering for our customers. That's a great fit, but actually the product grows with our customers as well, and Adam's at the forefront of that. Formerly, he's been with us for over a year, and I'll talk about the product in the demo in a minute. Formerly at VMware, he played a pivotal role at Pivotal. I had to make that joke, sorry, Adam. And you'll learn more about him as he speaks today. And then Zack has been with Tetrate for 4 years. He was formerly at Google, and his pun is that he was doing software pipelines at a pipeline company before that. He's based in and is currently in Birmingham, and just founding engineer at Tetrate, and has an interesting role because he does deep software work, which takes a lot of time and privacy and focus, and also is very active in especially in standards work. So we work with the National Institute of Standards and Technology, helping set US government standards for this emerging area that we are working in and collectively leading in. So it's a great place to be, and I'm glad you guys could join us today. This will be recorded, and we'll be sending you a link, I believe, to the recording afterwards, so don't worry about that. I think the slides will be included as well. And we'll be using this webinar as a recorded intro for a long time about what we're doing today. It's been about a year, almost exactly a year, I think a couple more days since.
Yeah, I think 2 days short. I was just looking, April 7th of last year.
All right, thank you, Zack. Yes, and these guys actually introduced TSB 1.0 to the world in a webinar right after its launch. So this is a reprise, and what I actually asked them to do today was to go through Tetrate Service Bridge kind of holistically while pointing out the new features in the Golden Gate 1.4 release, which shipped about a month ago. And that was following after our joint webinar with NIST on service mesh and zero trust architecture. So we have an awful lot going on for a startup. Some of you who are in larger companies may know how hard it is sometimes to get government and military accounts, and we have started out very strongly with them, with some names in financial services that we don't normally share the names, but would impress you if we did. So we've really started out with super challenging and interesting customers and who push us to the limits technically. So everything you see today is the result, it's a combination of the original inspiration of the founders and the people who have joined, working really hard to bring it to life, and then heavy input from customers, maybe more than most startups. So with that, I am going to turn it over to Adam and Zack. I'll be keeping an eye out for questions, and if we have time at the end, I'll feed those in to the presenters. Thank you.
Awesome, thanks, Floyd. Wonderful intro. Adam and I are excited to be back and talking about the latest iteration of TSB that's in customers' hands already. A little bit of background about Tetrate, and we'll go through this pretty quick. If you want a little bit more, we'll go watch last year's. Though we've definitely done one or two things since then, right? So as ever, the core team here at Tetrate is a lot of the original engineers on some of these projects that power Tetrate Service Bridge, which we'll be showing you today at length, right? Those technologies primarily being Envoy and Istio, as well as Skywalking and Zipkin, and some of the other kind of emerging technologies like WebAssembly, like NGAC that we're helping drive as well, right? We invest heavily in all of those projects. I think those stats are a little bit out of date, but we invest heavily in both Envoy, Istio, as well as Skywalking, Zipkin, WebAssembly, and others. One of the big things that sets us apart is our collaboration with NIST, which we've done since the beginning of the company. So, I think Floyd mentioned the company is about 4 years old. I've been here about 4 years, and we've collaborated with NIST, for about 3.5 years of that or more. And our collaboration started around next generation access control, which powers a lot of the multi-tenancy features that I'm going to talk about in just a minute. This is some of the coolest stuff that our customers get the most excited about with respect to Tetrate Service Bridge, the powerful permissioning system that it brings, so that when we go into especially large scale organizations, it makes it very easy to control who does what and to use the service mesh to implement regulatory controls and similar. Next generation access control is kind of the thing that powers that. And because of that, a really good collaboration with the folks over at NIST and their interest in the service mesh is a really powerful architecture, we went ahead and started to work together to collaborate on security standards. And I actually personally helped co-author some of those. These are the NIST standards for microservice security. Or rather, they are the recommendations for microservice security, the SB 800-204 series. We've had 3 of those so far, and we're pressing on with more as we cover kind of relevant area. One of the really awesome things about that is that we can make sure that the security controls, the best known security controls that are available are encoded in TSB out of the box, right? So we can go a long way towards making sure we're secure and safe out of the box and implementing a lot of the knobs, configuration, and even some of the processes that are needed there. And then finally, of course, we work very closely with them, even in terms of education, like conferences in this topic area. And that's something we're very privileged to be able to do exclusively. And of course, the core problem that we're trying to solve here is the connectivity of applications across modern environments, right? We're no longer just deploying in data centers, we're deploying across clouds, typically multiple because of mergers and acquisitions, or because we need our developers to consume the best in breed functionality in specific clouds. At the same time, we still have to interconnect that back to our legacy infrastructure, right? Back to, and not just legacy, because it's not going anywhere, right? For a lot of the folks that we talk to, the data centers that they have aren't going anywhere anytime soon, right? And there will always be a large class of applications that run there. And so we're left with the complexity of managing how our modern applications that are distributed across these computes and across these different networks can intercommunicate, and how they can do that securely, how we can deploy applications rapidly and safely in the context of that environment. And that's exactly where Tetrate Service Bridge comes, right? We want to reimagine how applications communicate as using what we call an application-aware networking platform. The goal is that applications can consume each other, using simple names, use the DNS name, and the underlying infrastructure should manage the discovery, should manage the secure interconnect. It should facilitate the communication, even if it's maybe not in the local cluster, right? Across the entire infrastructure, wherever it's running. And this goes beyond just the service mesh that handles the east-west communication, but out into application ingress and how applications are exposed to be consumed by each other. The application edge, how we actually get traffic into our clusters, and maybe even eventually out into the network edge, although that's a long ways off today, right? But like we said, that vision is that developers can easily consume those applications wherever they are. Is that they're running in the infrastructure securely and safely. Finally, I want to unpack that idea of central governance, collaborative control, and local enablement. This is one of the key things, and we'll talk about this more in the context of the 1.4 release, where we did the Golden Gate release, where we extended some of the capabilities here. But we think it's really important, especially again, coming from the governance and the security perspective that we talked about with some of the NIST controls and similar, right? That organizations be able to use the service mesh to apply central, controls centrally. Things like everything needs to be encrypted in transit. There must be an authorization policy. Communication needs to go through the DMZ. Things like that, right? But delegate down capabilities to security teams lower down and closer to application teams to actually develop the controls that make sense in practice for that part of the business. And the net result that we see there is that application developers in individual lines of business in the company are able to develop more rapidly. They're enabled to go and work. So how do we go about delivering this capability? It's a two-layered approach. First, and fundamental to it is Istio. And we deliver that as the Tetrate Istio distribution. And this is, for us, it's not a fork. We're never going to differentiate on capability that's in Istio. That's, that comes philosophically from us. We want as much capability in the open source project, in the underlying Envoy project as well as we can get, right? But some of the things where we do help provide value for users at the Istio layer includes, profiles for installation in a variety of different environments beyond the open source project. We run test harnesses on every single set of infrastructure that we have customers run on, to the extent that we can reasonably replicate that, right? And that includes a test matrix pretty far beyond the open source project in terms of the Kubernetes and platforms that we're running on, the non-Kubernetes computes like EC2 and vSphere that we're testing on, as well as the range of versions that we're testing across there, so that we can make sure that, even customers that are doing things like slower upgrades over longer periods of time are well supported, right? In that vein, we actually support every individual version of Istio for 14 months, and rather than the open source project 6 months. Again, this is to facilitate folks that have a slower upgrade cadence for critical infrastructure, right? At the same time, we're going to make sure that that security fixes are backported there so that they're not vulnerable, right? One of the big ones here, we're actually pretty excited about FIPS validation, not just compliance, but the actual validation, the stamp on it, which is landing, I believe, this week, if I'm not mistaken, there. And, so for folks that are working in FedRAMP environments, for folks that are touching government agencies or worried about some of the cryptography standards there, we've got your back with builds that are actually already available in Iron Bank. As well, so you can go get and play with those. And then what we're really going to be talking about today is the layer on top, Tetrate Service Bridge, that drives it, that drives open source Istio. And there's two layers that I like to talk about when we talk about Tetrate Service Bridge, and that's the runtime layer and then the management piece on top. It's important to remember that at the end of the day, everything that I'm talking about here manifests as Istio CRDs in your local Kubernetes clusters. But across all the clusters in your infrastructure where we're running Istio and managing it, TSB can start to provide an inventory of all the services that are there, right? We can start to do the runtime failover and discovery, and we'll show this in the demo today, both failing over across clusters at ingress, as well as internal application traffic. So we can really implement that idea of serving an application wherever it's available. At the same time, we don't want to spray traffic all over the entire internet, because it's expensive if we're routing to wherever the application is available, even ignoring locality. And so we're going to use the underlying Envoy capabilities to keep traffic local, keep it efficient and low latency, but be able to fail out to maintain availability, as we need it, right? We distribute mesh configuration across all the clusters that are enrolled. And you can imagine that, we're not just pushing raw, the same Istio configuration everywhere. But when an application developer comes to TSP and expresses an intent like canary my application, that might actually manifest as slightly different Istio configuration in different clusters, because not all your clusters are going to be identical. And TSP handles that specialization to the environment. And of course, if we're going to be managing across all these clusters, we get the status of those clusters back in. So we know, are they up to date? Do they have the latest configuration? If not, why not, right? What is there? And then can we go in and upgrade and manage the Istio in those clusters? And so that's the kind of runtime cross-cluster layer. Then on top of those base capabilities is the stuff that we're really, really excited about. And this is some of the cool things that we'll especially dig into today, which is the management capabilities that Tetrate Service Bridge brings over the base capabilities that Istio provides, as well as the multi-cluster capabilities that I just talked about in the lower half of TSP, if you will. And this includes, multi-tenancy and access control, and we'll dig into the multi-tenancy in more depth here. Audit logging for every change in the system, so you can go prove to auditors that you're in compliance, that the service mesh is enforcing encryption and transit, is enforcing authentication and authorization of end user access, and other similar controls that you want. Again, an inventory not just of the runtime services, but who owns them, right? So we can very quickly understand not just what's in our infrastructure, but who do I need to go talk to about that infrastructure? And we're going to tie it all together with visibility across the top, right? So that you can understand the global infrastructure, which of your services are communicating wherever it is that they're running, and how your actual system works. And we show that in a really natural way, exactly like if you're a developer on a whiteboard drawing it with boxes and arrows, right? We're gonna draw that topology visually. And again, this sits as a layer on top of open source Istio there, right? And so at the end of the day, there's Istio running in all the Kubernetes clusters that you're under management, across clouds or data centers. At the same time, we can go and enroll VMs, bare metal machines, and other compute environments like EC2 or ECS into the mesh as well. We can weave that single coherent infrastructure across the top using Tetrate Service Bridge. And now I want to dig into the Golden Gate release specifically and some of the new stuff that we're pretty excited about landing. So first and foremost, we've taken what we believe is the best-in-class multi-tenancy and extended it even further. So since even before our 1.0 release, we talked about the 1.0 release 363 days ago or so. But even before that release, we had a really sophisticated multi-tenancy system. And the reason for that is exactly what Floyd had mentioned. Right, we built this hand in hand with real customers with incredibly sophisticated infrastructure from day one. We literally got our first customers, before we started writing code, right? And as a result of that, we've had to grapple with those very real challenges of how do we bring the service mesh capabilities to a large organization. And we built out those primitives of workspaces, tenants, and organizations, which support a hierarchy that you can use to divide up your physical infrastructure. You can bring your existing identity provider like Active Directory, like LDAP and similar, so that you can assign ownership of those workspaces, tenants, and organizations to your existing identities and have them claim your physical infrastructure, so that it's really, really easy to control who can do what using the mesh where. We've taken that which was already an incredibly powerful set of capabilities, and extended it even further in the Golden Gate release. In particular, we're really excited to add configuration inheritance, very similar to the permission inheritance we had before. So now you can set defaults on the organization, on tenants, or on workspaces. And those are going to be inherited down across all the workspaces under the tenant, across all the tenants and workspaces under the organization. This makes it very easy to enforce invariants like there must be encryption and transit everywhere. with a single configuration at the root of your infrastructure, rather than having to templatize that configuration across every namespace, across every team that comes along, right? This is one of the things that we're really, really excited about. It also works really well for setting defaults, even for just traffic. Default sets of timeouts and retry behavior across the entire infrastructure you can set the same way. The second big piece here is that we've landed a permission scoped UI. So always, of course, everything you do in the API is based on your user credential, and we apply permissioning to all of that. But now in the UI, everything that you can see, click on, and view is scoped by the permissions that you have. So when we come in and look at the global topology, you're only going to see your services, the things that call your services, and the things that your services depend on, right? Your incoming and outgoing. You're not going to see the universe. And that's true for any user that comes in. That's true even for infrastructure administrators that own central pieces that are shared, right? This cuts across, including things like buttons and tabs in the UI. So you can very easily curate a set of views based on what the user needs. And they're not going to get distracted. They're not going to have a bunch of extra stuff around. And it's very easy to do information hiding in cases where you need it as well. The second key piece, building on top of the multi-tenancy there, is the idea of applications as a first-class construct. And so, TSB has modeled services from the very beginning, but we tend to not think about just bare services. We think about an application which is composed of a set of services. And usually that application will have, one or a few different interfaces that our clients consume. We have a variety of services in the back end that implement those, that implement that interface, right? And so we now support the idea of grouping services together into an application. I'll talk in just a second how you can start to configure those applications using an OpenAPI spec. And what this lets us do is very clearly delineate the interface that's exposed to clients, whether those are external third-party clients or other developers within our own organization. Understand the set of services behind that interface that implement that interface and how those link up, right? Which parts of the interface are satisfied by which parts of these services, how those backend services all interact with each other, and ownership ultimately of those services, right? And we provide this in a nice, concise view to be able to understand this application thing. And then on top of that, we start to bring API gateway features everywhere in the service mesh. And when we talk about these gateway features, we're really talking about what I call kind of the 80% use case that we see very frequently in modern environments for an API gateway, which is token validation, some rate limiting, and do load balancing, please, right? And those capabilities are there in Envoy today, and you can start to configure them everywhere, not just at the ingress, but inside and internal to the mesh as well. What we're really, really excited about here, though, is that you don't need to use service mesh nouns to configure them. You don't have to go and teach all of the developers in your organization what a virtual service is, what a destination rule is, or how to write a service entry for an external service you want to call. We focus all of this stuff into the existing interface definition languages. And in particular, we're starting with the OpenAPI spec. So you can bring your existing OpenAPI spec that you generate from your application, from your Spring Boot app, that you generate from your protobuf definition, that you get out of your, out of whatever the frameworks or libraries you're using to build your REST services. And taking that document as a baseline, you can start to add annotations to it to unlock service mesh behavior. And we're not stuck at this kind of blank YAML document, I need to write a virtual service. Instead, we get to bootstrap using that OpenAPI spec. And it's really simple stuff. At the most simple, we can do routing for services with just a single annotation, right? Including annotation, routing to different services per path if we really want to. And so it can be as simple as this, right? Take an existing OpenAPI spec, add one annotation that tells us the backend for the entire thing or for each method, give that to TSB, and we'll go implement that as ingress or as sidecar configuration that'll only route allowing the endpoints that the spec declares, right? You don't need to go write a virtual service that declares all these paths and all of that. But we also start to support a variety of common mesh functionality as well. So for example, sorry, we're skipping around here. Cores, looks like I deleted my redirect example, but of course, simple things like redirecting paths. So we can redirect here at the bottom. You can redirect users, for example, to V2, and of course, those can go to different destination. We can configure some of the easy functionality like cores, things like JOT-based or OIDC-based authentication, as well as underlying Envoy capabilities like the external authorization libraries, right? So all of these kind of common Envoy or mesh features that we typically want to use are there available in the OpenAPI spec to be configured at that layer. Things like retries, circuit breaking, and canaries tend to happen per service, not per application, and so they're down at a lower layer than the OpenAPI spec. But the OpenAPI spec lets us configure a lot of these common cross-cutting mesh use cases very easily with documents that developers hopefully already have. We're seeing it become increasingly common, especially with a lot of the customers we work with, that an OpenAPI spec is kind of the lingua franca. It's kind of the basic ticket for entry into the kind of modern cloud native platform. And then finally, one of the other key capabilities that landed in TSB 1.4 is the ability to start to implement a WAF everywhere, right? We think, if we think about a WAF traditionally, a web application firewall, it's traditionally been deployed as an edge appliance, right? And so as traffic comes into our system, we scan it and then we pass it in, and whatever happens inside happens inside. But one of the core tenets of zero trust is the idea that the network is already compromised, right? This is why a perimeter-based security model isn't effective. And if we think back, for example, to the Log4j vulnerability, one of the things that's frustrating about it is that we had to patch Java everywhere because we needed to be worried about things like pivot attacks internally, even if that Java application itself wasn't exposed to callers to do something like that malicious JDNI injection. We still needed to worry about things like pivot attacks that could land that malicious payload at some Java application somewhere in the infrastructure, right? It's not a strictly edge problem, especially as our topologies get more complicated, as we get more east-west communication inside of our infrastructure. And so we want WAF everywhere, right? And we've helped bring mod security into Envoy so that we can start to use mod security features and configuration everywhere. And the initial version of that shipped in TSB 1.4 so that we can start to enable common sets of WAF rules there at the sidecar as well as at ingress. And I think in our demo, if we have time to get to it, we'll show primarily WAF there at the sidecars to kind of highlight that internal use case as well. And of course, all of this is on top of the existing capabilities that I described up at the beginning, but just to summarize, that single pane view of the entire infrastructure with an inventory of services and clusters, the ability to link that back to the teams in your organization that own it. With cross-cluster, cross-cloud routing and failover, both at ingress to do things like canarying new versions of Kubernetes clusters and similar, as well as internally inside of application east-west traffic to keep applications available, right? TSB brings that apply to one place, go change configuration in one place, and we'll manifest it across the infrastructure. And finally, that first class support for compute outside and beyond Kubernetes, because it's all about bridging our existing infrastructure with our new modern infrastructure that we're building. And with that, I'm going to hand it over to Adam, who's going to walk through in a demo environment these kind of main points here, as well as highlighting some of the existing capabilities that are already there. Adam, take it away.
Yeah, so look, oh, perfect, you stopped sharing. So good deal. I got a couple pop-ups that my internet was unstable while you were talking, Zach. So if that happens,
I'll cover for you.
yeah, just jump in. So as Zach said, we're going to cover some of the stuff that has existed already, and then really focus on the new bit. I will point out, maybe if you watch the videos or see us demo TSB last year, we talked a little bit more about clusters, maybe got into the Istio layer. And I'll point out, as you watch me demo, it's going to be much more application centric. So I would love you to put on your hat and say, could this fit into the application developer's workflow in my organization? Meaning they're not writing YAML, but they're using the existing tools and semantics that they're familiar with. So the first thing I'd love to show you all, though, is the multi-tenancy of applications that Zach mentioned, and how we're able to plumb the platform and the global mesh in accordance with whatever is your identity provider that you've chosen. Now in this demo environment, it's using Azure AD. So I'm going to log in first as Adam. So I'm a little bit of a super user, not an admin, but I have a little bit of a broader perspective of what this looks like in TSB and in the overall application platform. So you'll notice there's a couple tenants here. So a tenant is, for lack of a better description, a collection of applications. Maybe it's a business unit, maybe it's a portfolio. This is then carved into workspaces, and that allows you to bind to physical infrastructure. Now, what we'll really highlight, though, is how we can take something like wealth management and look at, well, what are the actual applications that are deployed into wealth management? How do we reason about these microservices and these services, whether they're Kubernetes or on VMs, holistically? So I wanted to log in to show you, we got these three different groups of applications there, but now I'm going to log in as, the customer app developer. So I own the few services that are deployed in customer services. And to do this, let's jump to an incognito tab, so that hopefully I lose all my Azure AD cookies or whatever tracks me there. Yeah, great.
Yeah, because like we said, we're actually doing bring your own identity provider, right? Always. And so here, Adam, we're actually authenticating against Azure Active Directory.
Yeah, that's great, because I'm really bad at typing as I talk. So Zach gave me a little bit of a breather there. So I'm logging in as the customer app user. And after I authenticate here, you'll see I have a new, like I said, I'm really bad at typing at the same time.
Yeah, it's hard.
And now I'll have a new view where I just see my customer application that I'm interested in. I have a view of my singular tenant, and more importantly, my application. So my support portal application that I deploy to, and a customer 360 application. And I can very quickly get a snapshot of how these services are performing. What are the red metrics about the microservices that are composing these applications? And a good first stop to see if they're in good shape. And from here, we could very easily drill into, I think Reviews has a couple versions of it. So I could drill in pretty quickly to look at my application spread across different clusters, compare different versions of that. Now, this specific application that we've been talking about here, select all of them, is actually deployed across 2 public clouds. So we have some services here that are in Azure and AKS, and this is a GKE cluster. So imagine it's a scenario where maybe you have some applications that are part of the same portfolio, but some have been deployed to Google. Maybe they're using some of the data capabilities that they like in that cloud, whereas others have their application running in Azure. Here we're able to stitch together a global mesh and connect these applications. So as you can see, my API consumer here is calling across clouds to consume maybe whatever data API is being exposed by my application on the other side. And this is all handled seamlessly. You see the little locks here that indicate this is MTLS. So this is all intermesh traffic. So this gives me a contextualized view of just my clusters, just my applications, even though there's many more applications and actually multiple other clouds that are involved in this environment. So for the actual more hands-on demo bit, I'm going to switch now to a financial services application user. So I'm gonna log in as a different account here. Rather than customer app, let's switch to financial app.
Yeah, you can never type worse when people are watching, right?
I know this is, and these are some long names too.
Yeah, it is. Not short.
Everyone look away so Adam can type.
Good deal. So now we're going to be dealing with our wealth management application that I had pointed out when I logged in as an administrator. So now I have a different contextualized view. Maybe I have some DevOps responsibilities for these card services applications and wealth management that we mentioned before. And we're going to really focus in on these two applications, one that is market data, one that's kind of modeling, how we have an asset application. These, I get the same view, the same red metrics. I will point out this guy actually isn't connected in the mesh yet, so we have no metrics. We're going to do that live with our demo. So let's actually get right onto that. So we can take a look at our market
one
data.
thing I just want to highlight here real quick is that Adam kind of alluded to, we can actually start to show things that are not enrolled in the mesh yet. You can start to carve up the infra even before you go and roll out the service mesh to all these services. So that was kind of hiding under there what Adam said. Sorry, Adam, take it away.
Yeah, no worries. Yeah, I didn't want to go too deep into that for the sake of time. So our market data application isn't working yet. And if I go to quotes, this long URL, try and get a quote for Google, it's just going to hang there because I don't have anything listed on that yet. So again, I'm wearing the hat of a developer. I'm ready to roll out my application, the service mesh. What do I have? Well, I've probably packaged my container and I now have an API specification. So we're going to deploy all the mesh configuration just simply based on an API specification that will hand it. So we just simply need to tell it, like, what is the namespace where our gateway is running? Where should we actually deliver this configuration? And then one small hint in case we had multiple ingress gateways running, one small hint on which one we should bind the gateway to. So that's why we tell it what label. So now I'm simply going to hand the system, upload it, my quotes API. And so I'm going to apply this because it's going to take, maybe a few seconds I got to move the Zoom window, I'm blocking. A few seconds out to push that out to the clusters. But while that happens, I can show you what we actually deployed was, very simple API specification. This is the Spring Boot application. So I used Spring Doc to generate this. And has two API endpoints. And as Zach showed in his slides, the only thing we had to tell it is, what is the service within the global registry we'd like to be made available? And what is the listeners that we want to listen on? And so it now has blasted out all the needed configuration to my clusters. This would be deploying virtual services, gateways, destination rules, all the Istio config that's needed to now make this available. If I go to the dashboard and we look at the metrics before we move forward, I want to point out one interesting thing about this application. You'll notice that this is a hybrid application. So that means it's actually in both Kubernetes. I didn't put enough traffic on it, so let me refresh this a few more times. This is in Kubernetes and within a VM. So version 1 is a VM, version 2 is containerized. So now I'm actually exposing VM within the service mesh via my Swagger spec, my OpenAPI spec. And here we can see our traffic flowing in. We're able to see our dependencies, understand what security, do we have MTLS applied to it, and drill in, if we wanted to compare the performance of our VM versus our other version of it.
And you'll note they're graphically denoted as different as well. They're the icons for pods versus mixed services versus pure VM services are all different. So it's easy to tell at a glance.
Let's go back in. We're a developer, we got it running, but now we have a new request that comes in. Hey, we have some load issues. We probably need to implement some form of rate limiting. Okay, well, that's an API gateway characteristic, something that's now becoming part of a global mesh, as Zach alluded to earlier. So we can add just a few small incantations to this specification, and that automatically will be applied now to our gateway and the configuration that's controlling the service. So I just had a second version of that OpenAPI spec that I just uploaded. And let me save these details. So make sure that gets pushed out. You'll notice all I am telling it is, hey, I want to turn on rate limiting. I'm simply going to throttle per minute, and I'm going to look at an X user header. And so now this is going to use an internal service within Tetrate Service Bridge to rate limit requests once I go over that. So I no longer can use this. I don't have any plugins to add that header. So I'm going to jump out to my command line here and just start to send a bunch of requests with X user Adam, and I will shortly start to get. Maybe I didn't save it. It should have been out there. Let me double check that the config made it. So let's try sending a bunch of requests more. We should get blocked.
Yeah, the beauty of, there we go. I was going to say, beauty of an eventually consistent system, right?
Now we're getting 429. We're getting rate limited, with a little message from Envoy saying that truly is the case. So fast forward, a couple weeks. Now we have some new security requirements for our application. So let's go back to our Swagger spec, and we're going to now add some JWT validation. We're going to authenticate and authorize based on a JWT that the client would pass in. So I just uploaded another version of the OpenAPI specification. So right below rate limiting, we now see that we've added the configuration to point it to an auth0 JWT issuer. We're going to look and validate those specific claims against the issuer, and we're going to look for a specific role that says only market data users are able to access my quote service that I've been invoking. So as I save that, my browser won't be authenticated. So this guy obviously is getting rejected. And if let's see, I got to export a token. So I'm going to just simply request from auth0 a token. First, I want to do for a user that shouldn't be. So this is going to be for the plain user. And remember, we're looking at specific claims. So this guy was denied. I got a 403 here. And we can inspect the token to see, well, he simply has a JWT coming in. It's valid. We validated it, but he only has a general role where we said, hey, this guy has to be market data. Otherwise, he can't get these real-time quotes. So the other user I was about to make this curl from. We can do this now with the market data user. And this time it goes through. And as you would probably guess, it went through simply because we have the right role. So we had a proper claim on our JWT that we got from auth0 as we went through that flow. So I was
again,
very
this
easily,
is, oh, sorry, go ahead.
Not have to get into any authorization policy, request authorization, anything within the Istio level, simply configuring issuers, claims, and how I want those claims to be enforced on my requests.
And similarly, we didn't have to change the application at all, right? So we didn't touch the app, anything around the application. We only changed some of the things that the mesh is performing. And so, from the application's perspective, it will never see an end user that doesn't have a credential with the correct claim, right? And we don't need to go in and change the app to opt into that SSO.
Yep. So we've been starting to build out an architecture, if we look at the topology of our applications here, that allow us to start to have a distributed gateway, right? At our sidecars or at individual localized ingress gateways, start to apply this API gateway like functionality. And as Zach alluded to or showed in the slides, one last bit that's often pretty important here is applying security policy from a WAF or an injection standpoint on actually inspecting the requests. So let's go back to our applications, and now imagine the scenario that we potentially are moving our organization a little bit closer towards zero trust. And so we're not simply having a WAF at the top, but we are quite worried about lateral movement. Someone who is going to potentially pivot after they've made an exploit like log4shell and do some sort of SQL injection attack, cross cloud scripting, something like that. So I've simply just attached to a Kubernetes pod that is running in the same cluster that we've been using thus far. And these commands are a little bit long, so I'm going to copy and paste from my little helper text pad. And so first, we're going to try and move laterally across our Kubernetes cluster, and just call this HTTP bin service with a signature that looks like it could be a cross site script. And so I get a 403. That's the configuration here that should be returned by this CORS rule set, which is a set of the OWASP rules for a WAF firewall. Likewise, the second one we could also look for is SQL injection. So if I try and pass in some data that looks like I'm trying to override some query parameters, I get the exact same thing. I get blocked at the sidecar. So I'm getting blocked at the point that I'm trying to actually enter the pod as I traverse across the Kubernetes cluster. What we can take a look at is actually the logs of that sidecar and see, that in fact it said, hey, this is not good. We just detected, SQL injection. We looked at this OWASP rule set library that is going to be constantly updated, and we detected that this was something we had to, in this case, return a 403 to. So that covers, the real interesting new things that help you get your mind around that these are now application developer semantics, not necessarily low-level infrastructure, Kubernetes, and Istio, things that we're dealing with as we configure our applications. Since we have just a few minutes before we get into the Q&A, we got 10 minutes before the top of the hour, I'll point out something we'd like to demo often is how this mesh now is going to be geographically aware and cloud aware. You'll notice for this financial or wealth management workspace and set of applications that spread across these two AKS clusters. And this is the EKS, the Amazon EKS logo. And my application is actually spread across multiple regions, multiple zones of these cloud providers. But you notice there's no arrows that actually connect them. The only thing that connects them is this edge load balancer. This is an edge load balancer that is the entry point into the mesh, knows then how to use mesh routing to discover endpoints in these respective clusters. But once we determine what cluster we're landing in, unless anything goes wrong, we're going to try and optimize and keep traffic local. So that's what is happening here. We're at a good steady state. But if we simulate a failure, so we're going to simulate bringing down one of our pods. This is in, let's see, which cluster is east. So this is the east cluster. So we're simulating a failure. Maybe we had bad configuration pushed out. Maybe we actually ran out of capacity and had to roll our pod, but then it couldn't get rescheduled. Any number of reasons that this backend, this guy here, disappears, we'll now see an automatic failover. And sometimes it takes maybe 10 seconds for the metrics to start to appear, and we'll notice a new line. But we could pretty easily test this by going to the actual sample app and testing its routing. It's HTTPS. And so by connecting to my back end dot, you'll notice my request is coming from cloud A01, and I'm not going to get a response from cloud A01. I'm getting a response from cloud A02. So I know my application is healthy, though the metrics hadn't flowed in yet, but hopefully with that little jaunt over to the other screen, our metrics would have started to flow in. Maybe if we filter in the last 5 minutes. That will encourage it to, to move faster. Not quite yet.
It never does
All right,
do
well,
it fast when you want, does
Yeah.
it?
So let's move on to, it looks like there's at least one question in the chat box. So let's start to answer those and then wrap things up.
You're
Yes,
muted.
thank you. Unmuted myself. To quickly explain the difference between TID and TIS. TID is free and available for anyone who wants to download and use it. And that's a service that we provide for the community. You know, we want to raise the level of practice out there, of course, and have people have a good experience with Istio. Tetrate Istio subscription is our support, paid support for Istio. And that works out well for us because our customers are quite serious. And when they get into production or close to production, they want and need support. You'll see that there's an old saying that there's no problem in computing that can't be solved by adding another level of abstraction. So the abstractions, the carefully defined and well implemented set of abstractions that are available for you in Tetrate Service Bridge give you a lot of power. We are going to publish something soon about another abstraction we didn't talk much about today, of workspaces. It really is impressive how well you can organize things. Imagine your developer's relief when they can't screw up other people's stuff. You know, basic things like that are quite achievable here. And this is amazing capability today, but we all know the pressure that's out there on security. And so what's amazing today is going to be expected tomorrow. And we see government and some large organizations leading the way in using this technology. When that gets out there and is widely used, which is starting to happen, there's going to be a lot of hurry up around people who haven't done it yet. So with that in mind, let me pass on a few questions. First of all, there's a little wonderment out there with the kinds of things you guys are bringing up in this demo and that are contained in TSB. Is this more a research effort, or is it a company? And is this some kind of a framework that you do fun stuff with, or is this an actual product? You know, what's the experience for people who buy TSB and want to get in production?
Yeah, so yeah, it's not a research project. We do have some cool novel research that powers some of the underlying stuff. You know, NGAC I mentioned, you know, was I said it's actually been a NIST standard. It's been an ANSI standard for about a decade now. Although we've helped partner with NIST to bring kind of industrial grade implementations, for example. And, you know, there's novel IP there around the access control system itself and similar. But the bread and butter stuff that we're doing here is, you know, managing the mesh on behalf of organizations, taking into account, you know, the central security team, the central networking team, versus the needs of the individual application development teams, and implementing a system that kind of fits how we see organizations divided up and the ownership that we see there, right? And so that's really what we're doing, right? Is kind of taking the service mesh capabilities, the gaps there to actually utilize it fully in an organization. To you know, it's a lot more than just being able to flip some configs, right? To be able to realize the value of the service mesh in the context of a large organization. And that's the key pieces that we solve. And it's there, valuable and in production for, you know, real folks that are doing stuff that, you know, you use like every day. You know, it's not a toy, it is, you know, here and now.
Okay, good. Thank you. Question, I think that's probably more for Adam. What's it like for customers who have a use case or choose a use case that fits well with the product? What's the onboarding stand-up experience like? What kind of work does the customer have to do to get this thing up and running?
Yeah, so I think you bring the starting point is the customer use case. So once we have that defined, it's a two-pronged effort. One, to enable the team. I think as all on this webinar will agree, any new technology change that is similar to this, it's a little bit more organizational and practice and enablement than actually how do we build architecture and how do we do this stuff. So that will be the focus on enabling the right operational team. And then twofold, laying the other aspect is laying the fundamental architecture that allows you to deliver that small build, that small use case, and set yourself up to layer in additional capabilities, additional functions. And we quite often see organizations don't start with everything that I just demoed. It's very often, hey, I'm moving towards zero trust. How do I get MTLS? Great, I got that. Let me move on to the next thing. Let me move on to the next thing. So once we have that initial use case hammered out, then we begin that journey of build the foundation and then increment and iterate.
Great. And then we're getting near the end of time, but there's a really good question. We just have time to, I think, to answer it. But maybe we'll each have a little bit to say about it. Bill is asking, can you interface the service mesh to traditional IT? He said OA. I'm not sure what he means by that, but you guys probably will. And a microservices world. So I'll quickly mention there's something called a strangler pattern that we bring up quite a bit, of peeling things off of your traditional application and bringing them into the service mesh world, while the core functionality you don't have to change. Office Automation Exchange, that's what the OA is standing for. Thank you, Bill. Let me start by alphabetical order. Adam, what you have to share about that, about interfacing to traditional IT, Office Automation Exchange, and so on, as well as.
Yeah, so I'll talk more broadly. We might want to use the word legacy. We might want to use the word traditional. Take your pick. We don't want to use those words to say these things are old and crusty and have to be changed, because this is probably what is making 95% of your revenue in your business, though there is a shift. So those types of systems, the answer absolutely is yes. And I apologize if it didn't ring through in the demo. The market data quote service that I was showing you was on a virtual machine. So that had been onboarded into the mesh. There's a sidecar running there. We're doing mesh discovery, MTLS, the full security gamut on that, what we would call quote unquote legacy VM.
Yeah, so and then I think maybe the other side of Bill's question here gets to some like the people and process things there as well. So there's a couple different kind of touch points, right? So in general, the service mesh is kind of interesting in that it brings together a bunch of different, what used to be disparate groups in the organization. The networking group, load balancing group, some of the application framework, application development, infrastructure groups, some of the application security, infrastructure security, and a bunch of these different stakeholders, right? In general, what we see, one of the things that TSB tries to do is meet organizations where they're at, bringing this new capability that the service mesh provides, right? But trying to meet you where you're at with your existing processes and people, right? Exactly like Adam says, so that you can start to incrementally adopt these capabilities, fitting them into the model that you have today. And that model is going to it's going to be a give and take. It's not going to be purely the service mesh just fits into what you have. Part of that's a good thing, right? You want to update your security models. You want to update your operational models in light of new capabilities as well. But this is a big goal. This is why we have shared ownership with persona-based views and things like that in TSB. This is where a lot of the kind of reading matter and some of the white papers and blog posts and similar that are coming out over the past week and are going to be coming out in the next month or so are going to touch on exactly some of these topics of how do I start to realize the value of the service mesh in my organization? Who are the teams I need to go wrangle and talk to? What are the things that I should talk to them about? So that you can socialize the idea of the service mesh across the org, get those stakeholders involved, and so they can start to realize some of the value that it brings for their roles as well, right? And then specifically from the angle of automation, there's a whole bunch of different stuff we can talk about. And there's probably another webinar we'll do a little bit closer to the TSB 1.5 release, our next one in about a quarter. specifically around GitOps integrations and some of the process automation things there that are really exciting for fitting in with some of those kind of larger initiatives that are also happening in IT departments around infrastructure as code, for example.
Well, everyone, as you can see, we actually enjoy this stuff. So we look forward to encountering you out there. And thank you very much for attending. And we'll share the recording after this finishes up. Thanks again, and bye for now.
Thanks, everybody.
Thanks all.